Before we get started, we're going to ask you, I think, just one poll this morning, and it will give us a better idea of how much experience you have on the cloud, and it will help the speakers calibrate how they talk about the cloud and what they're doing today. As we go through the webinar, please feel free to ask questions. We will be answering all of those. The questions can be asked if you go to the control panel and go to webinar. It's down toward the bottom. It says questions. We'll be answering all the questions through the control panel, but we'll also be taking some of them at the end and having a live discussion about the ones that seem to be most applicable to a broader audience. So as you're selecting the poll results are coming in. So just select one. I think it's about there. Okay, so let's look at the results. Okay, so we've got probably an audience that has done more on the cloud than audiences we've had in the past, which is fabulous. So with that, let's get going. Okay, here are our speakers today. We're very pleased to have Bernard Golden with us. He's the CEO of HyperStratus. He's held very senior positions in corporate IT, enterprise software, global consultancies, and venture capital firms. Besides being a speaker, he's also a writer and an author. He's the Virtualization and Cloud Computing Advisor for CIO Magazine and the author of Virtualization for Dummies, which I understand is the best-selling book on virtualization these days. Also joining Bernard and I is Ed Goldberg. Ed is a very well-known character and friend here at RightScale. He's been working with us for the last couple years. He is an entertaining speaker. We'll do the demo today, and he's also a very accomplished systems architect and engineer who's worked on a wide range of systems, all the way from nuclear reactors to keyboards and printers. And then joining us is Daniel Howard. He is the person who will actually be answering the questions for you. So that's the team today, and here's the agenda. After we do these opening remarks, we're going to have Ed give you a quick preview of the demo, and then Bernard is going to launch into comparing development and test in a traditional data center to development and test on the cloud. Then I'm going to give you a very brief intro to RightScale. I promise to keep it very, very brief. And then Ed is going to talk about why you would use a cloud management platform for test and development, and then actually show you how it works using RightScale. At the end, we'll open it up to Q&A, discuss some of the questions that have come through. And just to remind you again, keep those questions coming through the question window. With that, Ed, I'm going to turn it over to you.
Well, thank you very much, Betsy. My name is Ed Goldberg. I'm the cloud evangelist for RightScale. And my goal today is to actually drive home Bernard's point. I'll be doing a live presentation where we're going to do real test and development in the cloud. I'm going to be using a Drupal example with a then cascading style sheet developer environment. And we're going to show you how you can actually practically, I'm going to do it live in the demo, do test and development with a developer, both remotely and locally in the cloud. So without further ado, I'm going to launch a few servers. Let's get back to the slideshow. And when you get to me, we're actually going to drive home and actually show each one of the points that Bernard talks about. Back to you, Betsy, for a moment.
Okay. I think, Bernard, why don't you take over?
Sure. So
okay, Bernard?
Let's go ahead and get started. And, let's start. Many people on this webcast are experienced with the cloud computing, but some may not be. And I wanted to start with a brief overview of what cloud computing is, and particularly its characteristics, because those really affect and impact the reasons why doing development and test in a cloud environment makes a ton of sense, and why it should be on every development organization's kind of radar about moving forward. And you don't have to have been around cloud computing long to find that everyone and his brother has a definition. Rather than sort of throwing ours into the mix as well, what we do is we really point to the UC Berkeley Rad Lab definition. They put out a report about 6 months ago. RadLab is an industry academic consortium located at UC Berkeley. And in their report, they identified 3 primary characteristics of cloud computing. The first is huge resources, what they called the illusion of infinite computing resources available on demand, thereby eliminating the need for cloud computing users to plan far ahead for provisioning. And what that essentially means is kind of when I want it now, and I shouldn't have to think about is there enough there for me to get access to. The cloud provider's job is to provide enough resources so that from the perspective of a user, you just demand and it's there. Obviously, there's truly no such thing as infinite resources, but it should be the illusion. In other words, for any realistic use case, I should be able to get access to as much computing resources as I need on demand.
Bernard, can I interject a point right there?
Sure.
I think it's also important to have reasonable limits and to be able to track and have reasonable limits to those provisionings. I don't want to hand over to my developers an unlimited environment. And maybe speak up a little louder. I'm hearing you, but you're a little soft.
I'll do what I can. Is that any better?
Oh, much better. So reasonable limits, I think, is an important part of that provisioning question.
Yeah, absolutely, sure. The second characteristic that they really pointed to was no commitment, meaning the elimination of an upfront commitment by cloud users. So you don't have to sort of say, I'm going to need 8 machines for the next 4 years, and so I better buy them now, or I'm going to need 80 machines. Essentially, I'm able to demand what I want with that infinite scalability, and then when I'm done, I release them back into the pool, and I have no ongoing commitment to them. And that's very attractive because that enables you to, fearlessly use compute resources without the concern that, oh gosh, if I really scale up, I'm going to be stuck for a long time with a lot of computing resources that I'm not using. So lack of commitment or no commitment, is another characteristic. And then the third characteristic they identified was pay by the drink. And what that means is really, I only pay for what I use. So if I release a lot of resources after having used them for a week or a month, I am no longer having to pay for them. And that makes it very tied to what I use, I actually pay for. What I'm no longer using, I'm not stuck paying for. And so those 3 characteristics, infinite scalability on demand, within reason, of course, Ed, no commitment on a long-term basis, an ongoing basis for those resources that I've used, and paying by the drink, paying for what I use, is the 3 characteristics. And what we're going to talk about now is, as we go to the next slide, is how that maps into kind of traditional IT, which doesn't have those characteristics. I mean, they tend to be much more sticky, much more fixed. And if you look at development operations, and these are classically the 2 organizations that have to interact for developers and QA folks to be able to get their job done. If you look at their charters, what they're told to do, what their objectives are in terms of their role within the organization, they really are kind of at loggerheads. They may not necessarily be arguing as this picture depicts, but fundamentally, what they're chartered to do is in conflict with one another. So if you look at kind of the working process, the way those groups want to work, the way they need to work to fulfill their task, from operations, they need to be very deliberate. Most mainstream IT organizations will have very structured processes. They'll have a lot of checks and balances. They'll want to make sure that nothing gets done without really being tracked. Whereas if you look at developers, they want to be agile. A developer, kind of the classic case is, I've got an idea, I want to start testing it out, I need to do something, I want to get started now. And, kind of you need to go to a change control meeting, and you need to do a request for resources, and it's got to go through the whole process, and it might be available in a week or 3 weeks, is really frustrating for developers. Not to mention it really hampers and hinders their ability to be creative, because when you've got an idea and you want to get going, and then you have a significant delay, it's a real problem. You look at budget, most organizations put the majority of their budget toward their operations, toward their production systems, and that makes sense. You want to make sure that you're capable of providing the functionality and the responsiveness that your applications need. The challenge for developers is they typically don't have much budget. A lot of the budget for infrastructure is weighted toward operations, and so developers are always kind of short-handed. And that creates a real issue because as they try and do their job, they're hindered. They can't get a hold of the resources they need to develop against. In terms of the use profile, operations, of course, wants a very deliberate, very structured, very constant kind of use profile. They try and bound how much resources they use and, settle it in over a long-term basis. Whereas development is typically very spiky. I'm going to do some work. I'm going to try something out. I'm going to spin it up. I'm going to, compile my system, get it up and running for a while. Oh, something's not quite right. I need to go work on it. So I'm going to shut it down and go back and, think about it, do some chalk talks, design work, whatever it might be. And so it's a very spiky use pattern, and that doesn't fit very well with operations, which is trying to come to a very consistent way of doing, of running operations. In terms of the topology, meaning how the application is actually set up and run, is it multi-tier? Is it run on numerous machines? Again, operations wants that to be very stable. They don't want a lot of stuff coming in and out of an app because typically that destabilizes it. So they want, they want to put it up and leave it up and not touch it. Whereas with developers, it's key that they be able to, spin up new instances, try new topologies. What happens if we partition this application and separate part of it off to another server? What do we have to do to test if it's, if these different servers can communicate with one another properly? So it's a very dynamic kind of topology that is always being experimented with and looked at. And again, if you try and put that into a production infrastructure run by operations, that's very frustrating for both parties because the operations groups want to say, let's not mess around with stuff. And the developers say, well, I've got to test it out, I've got to trial it, I've got to make sure it's going to be ready to go when we put this new app into production. I think Ed made a very good point when we were sort of preparing for this, is that a lot of times you have to actually try your app out in a production-like environment to see how these different components, these different servers, these different partition parts of the application actually interact in terms of latency across the network or data throughput and so forth. And so it's really important to be able to provide a production-like environment. And again, that's very difficult when you're trying to go to an operations group that's trying to not destabilize your environment. And then finally, when you get to load and scalability, well, that, for most operations group, has already been dealt with. They've already evaluated. They've done capacity planning. They've figured out how much they need, and they leave it. Whereas for developers, it's very difficult. The default development platform these days is a laptop, which is great. You can run virtualization on it, run a lot of virtual machines. But when it comes time to say, how does this work in a real-world environment? What if I do very heavy loads? What if I have very large data sets? What if I want to test the ability to dynamically respond to changing loads? It's practically impossible unless you go into a real production-type environment. And so that's a real challenge. And so the point of this is that in most environments, development has a very hard time doing kind of real structured work in terms of creating new systems because they're interacting with a group whose charter is to really avoid the kinds of things that development wants. If we turn to the next slide, we can look even within development, even with the classic, the different roles within development organizations. You have development, typically, software engineers and so forth, and then you've got QA, and you end up with issues between them. And one of the classic ones, and I've lived this, is contention for equipment between development and QA. During the development cycle, the developers get all the machines, and then when it comes time for QA, the QA group says, okay, great, I've got to get some hardware to run this on. And the developers aren't ready to give it up, or they want it to be available in case they need to fix bugs. And so you end up with this kind of fight between these two different groups who both need to get their job done so the product can get released. And so you want to find a way that you don't have to contend for that equipment. There's extended QA cycles due to environment install and configuration. Traditionally, what would happen is, my developers would turn over a set of machines to QA, and the first thing QA would have to do is kind of start from scratch and reinstall everything from scratch to make sure they had a clean environment. And so it might be the case that before any actual quality assurance could be done, there might be a week of just installation configuration, which is a week of not actually doing productive work. And that's a problem as well. I've often been bit by the fact that QA is unable to recreate the dev environment. They will be told, oh, the application requires these components, install all of these things, configure them this way. They'll do all that, and then it won't run. And after an extended kind of tracking it down, you'll find out that the developer had a library or a component or a separate another application running on his or her machine that they weren't really aware of. And so then the QA group has to find out about that and then go back and install that. And while you're trying to track that down, again, it's frustrating and really delays the ability to get work done. For QA, again, if developers have a hard time getting resources for scalability load, so do QA. And so that's very frustrating. And that's typically a part of their job. As part of their test plan is testing scalability and load. And so being hampered from having access to enough resources obviously really hinders the ability to fulfill those responsibilities. And overall, this is just ends up wasting money, time, and human capital. You have people sitting around waiting for machines. You have people spending a lot of time configuring and installing software, which is, let's face it, pretty boring. QA folks get very frustrated by doing that kind of very manual, kind of boring work. So you really have a lot of wastefulness there. So QA has issues around this traditional development environment as well. Let's turn to the next slide and talk about how we can use cloud computing to help the developers. So looking at the issues we identified, agile development, really key. It's the mantra today. People want to get started. They want to experiment. They want to try something new. Well, the cloud characteristic that really supports that is on-demand resources. I'm ready to spin something up. I want to get started right now. I have an idea. I want to test it out. I can easily go to the cloud and get those resources. I don't have to call somebody up and see if they can identify some spare resources and then put somebody on them to make them available, assign an IP address, all those kinds of things. Fantastic ability to leverage agile development. The spiky usage. I'm going to spin up and do a bunch of work, and then I'm going to shut it down for a week while we do some other stuff, or maybe while we do some design for the next release. Again, within traditional IT, that's really difficult to support. But in cloud characteristics, I have no long-term commitment. So it's very easy for me to use it for a day, a week, whatever I need, and then shut it down, and I can walk away from it. And I'm not stuck paying for a lot of equipment that I'm not being able to use with high utilization rates. Low budgets, cloud computing paying by the drink is phenomenal. I was spinning up some stuff this morning, and I mean, you literally are sort of paying, pennies per hour, which is a great way to take a group that doesn't have access to a lot of budget and make that budget stretch a lot further. Change the topology around as you want to experiment with development. You want to try partitioning your application, putting in new tiers, or extending new machines into a particular tier. The on-demand resources supports that very well. It's very easy to add another server into an application topology and see how that works, see if it aids the functionality and so forth. And Ed, I think you're going to be actually demonstrating a kind of a live changeable topology later in the demo, right?
Yeah, one of the things I'm going to be doing is literally hitting every one of these points. Actually, Bernard, I think I'm going to add a little bit more about that QA step and clone our deployment and make it from our development deployment to our QA deployment. But I think I can hit most of these. Give me a chance to set up a few more things, and we'll move into a demo that really hits most of these points, I think.
Right. And then, again, the load and scalability, again, on-demand resources. It's very easy. And I'll talk about that in the next slide, which is actually how QA works with cloud computing. For the issues that QA groups face, the equipment contention, I've got to go over and fight with the development group to get some access to some machines. That goes away with the on-demand resources. They can get their own machines, spin them up as they need, very easy access. They don't have to go ask for permission. They don't have to fight. They don't have to go to a manager to kind of say, I need them, well, he needs them, what do I do? They just use their on-demand resources. That extended installation configuration, cloud computing really does a great job with this because you can take an existing application and very easily clone it and set up a new instance devoted to QA. And I know that Ed's going to be talking about that, and that is a fantastic ability within cloud computing. Recreating the development environment, again, that cloning really cuts down on that because you're taking the exact same thing that developers are running. So there's no question about does this mirror the existing development environment? Do I have everything present? Is everything configured the same? Are there any applications or components missing? No. You're cloning the same server, so you know that you're going to get this exact same functionality, which is fantastic. And just kind of when it flows the other way, when QA finds a bug, it's very easy to say, yeah, I know this is exactly the system you have. So you will be able to recreate this. You don't have that, well, I can't recreate it, but it's a little bit, my system's a little different than yours. So this cloning really excellent for that. Load and scalability, again, on-demand resources really helps that. We worked with a company that needed to do load testing with a large number of users against their application. They wanted to spin up something like 1,000 users against their application to make sure it scaled properly. As they added additional users, that the system responded gracefully, could accept all the connections, could provide appropriate response time, and so forth. I mean, obviously, trying to do that in a physical environment would be really difficult. You have to find a lot of machines, get them all set up, and it would take forever. Instead, what they did was they essentially loaded up a bunch of instances up in EC2 and ran a lot of browsers in those things, spun up 1,000 instances, ran it for over the weekend, shut them all down, confirmed what they needed to confirm. Cost them $100. And so that was, an excellent use of cloud computing to solve that QA load and scalability stuff. And then the time, money, human capital stuff, people are able to be productive much more quickly because they can get the resources they need on demand and they can pay by the drink. So if we look at the next slide, I'm sorry.
And Bernard, it's really important, you were talking about that load testing. Not only are you getting machine instances on demand, you're also getting bandwidth to the internet. So that load test you did didn't interfere with your bandwidth allocation for operations and production, right?
Yeah, that's a really good point. A lot of times operations groups say, I don't want you messing around with your thing during working hours because that'll screw up the performance of our production app.
Right,
so
exactly.
You're going to avoid that kind of situation.
So it's not just servers on demand. It's not just operating systems and software. It's also bandwidth on demand, which is really an important point.
Yeah, absolutely. I mean, that's an excellent point. And thanks for adding that in. There are some challenges around cloud computing. I don't want to make it sound like, you just sign up for the cloud and every problem that you've got goes away. And moving to cloud computing actually presents some issues that you have to look at and figure out a way to address. One is, how do I integrate with my existing development tools and processes? I've already got something in place. If you come to me with a solution that says it magically fixes all these problems, but by the way, you have to throw away everything that you do and all the processes you have, well, that's probably not as useful as you'd like, right? I mean, in fact, it's probably unworkable. The version control and proliferation of VMs, this ability to clone easily, this ability to create new instances and hand them over is fantastic. It gives you much more flexibility. But, it poses the challenge of, how do I make sure I've got the right versions that I'm running with? How do I make sure that I'm keeping track of these things? And so that's a really important thing. And both of these points Ed's going to be talking about and demonstrating with his demo. Making scrub data sets available. That is a little bit different dimension, which is, if you're moving data up into the cloud, if you have privacy constraints or security issues around your data, before you move it out of the confines of your data center, you need to make sure that you've looked at it and ensured that you're not going to be causing any problems for making data available or something like that. So that's a kind of a process and something you need to put into place as part of your project planning. Integration with systems inside the data center can be also a challenge in that, excuse me, sometimes integrations between applications are done on a kind of a very custom basis. Like, it might be something like, we're going to call directly into the database of that other application. We're going to write calls from our app into that database. Or it might be something like, we're going to use our internal IP addresses to get at that machine so that we know what we can integrate. When you move your app out into the cloud, if it needs to talk to other applications inside the data center, you have to have some kind of interface that's available on a public basis. And really, that's, this is kind of the whole motivation behind the SOA movement. So it might be a forcing function for your applications to start moving in that direction, but it's something to think about. Moving from QA to production, you have to think about, if I'm going to keep this app up in the cloud, but I'm going to move it to a production instance, how do I manage that process? And by contrast, if I'm going to move it back into my internal data center, I'm going to do all my development and test out in the cloud, but going to move it back into the internal data center, how do I manage that process? And then the overall software development lifecycle. How do I manage the, I'm doing alphas, I'm doing betas, I'm handing this over to QA, and so forth. something that you really have to pay attention to in the cloud environment because you have less knowledge of the details of the infrastructure, right? You're just putting applications up there. The cloud provider is figuring out how to locate them, what machines they go on. So you really need to pay attention to that. All right, I think we're about ready to go do the demo, aren't we? Is there another slide here that we need to go through before that? I think.
Yeah, Bernard, I'm going to just give them a brief overview of RightScale before Ed shows them how it works. So thank you a lot. That was very informative. For those of you who don't know RightScale, we've been helping our customers manage cloud deployments now for, really it's almost 3 years. It'll be 3 years in December. We have 20,000 users, and our platform has launched over 600,000 servers. We have a range of customers from very small Web 2.0 startups to large multinational corporations, and they're doing all kinds of things on the cloud, from scaling up websites to grid computing. They're executing backup and recovery strategies, and of course, they're developing and testing on the cloud. In fact, this morning I was talking with one of our customers, and he said that it was amazing that he could stand up 50 servers and recreate a real production environment up on the cloud so that they could test one of their applications. So it's very exciting to be able to do this for the development groups and the QA groups. Our platform is a complete management environment. We work with the cloud infrastructure providers, and that list just keeps growing. We started off with Amazon. We added GoGrid and FlexiScale, most recently Rackspace. We also work with public or private clouds that have been built with Eucalyptus or that will be built with vCloud Express, the new offering from VMware. With RightScale, you can architect with proven cloud-ready solutions. We have a number of those ready to go. You can integrate your own software, integrate technologies from our ISV partners, as well as components from the infrastructure providers. As you deploy applications, you can take advantage of our automation that ranges from simply launching a server that dynamically configures itself without any human intervention, and it configures itself within an entire system so it understands its role in that system and how to operate in the system. And then we have auto scaling, which I think most people think of the cloud as delivering, and also our system supports automated maintenance and remediation. So as systems change, we can do as much remediation as our customers are comfortable with. Our customers manage systems, not servers, so they think about groups of servers, or what we call deployments, that work together and adapt as the environment changes. So as servers go down, as databases crash, as demand grows, you can architect these deployments to automatically adapt to those situations or to simply notify you and you take action at that point. Our users don't lose control of their users and costs. We have management tools that help them manage user permissions and costs. You can tell them how much they're spending on the cloud, and we even predict how much you'll spend between now and the end of the month. So as you're building, as our customers are building these deployments, the server configurations, it's all saved in RightScale, and over time what that becomes is a configuration management database or a repository of your corporation's best practices, and it becomes incredibly valuable to retain that learning and then share that learning across your organization. And finally, with RightScale, we've been designed from day one to operate on multiple clouds. So while there might not be a lot of cloud alternatives today, we make sure that our customers retain future flexibility so that if a cloud becomes available that better meets their needs, they have the ability to move there. So that's a little bit about RightScale. We don't see lots of questions coming in, so let me remind you that you can ask questions through the question window at the bottom of the GoToWebinar control panel. And with that, Ed, I will turn it over to you.
Well, thank you very much, Betsy. I'm going to be talking about the answers to the questions Bernard just posed. And boy, Bernard, you gave me a tall list and set me up for quite a wonderful demo here. What RightScale does is it helps you integrate with your development tools. I'm using the word your here. I want to integrate into your environment and provide you predefined and tested stacks. By stack, I mean basic machines that run the way you expect them to. Standard CentOS machines, for example, that will be used in the demos today, that contain the basic operating system. And you can layer on top of those systems as a service and put your application using your source code repository systems. Best practice system level designs. We tweak these systems to be standard server systems. They're not desktop systems pushed in the cloud. These are best practice server systems. Primarily in my demo, I'll be using CentOS once again. Configuration management built into the templates. What that means is managing your configuration of servers is built into a templating technology, a control management system. So when Bernard was talking about this ability to recreate an environment, the process is built into the templating systems, as I'll show in a moment. And then when you go from test to QA to staging to production, all of that information moves forward with the configuration system. Lifecycle support. RightScale is really all about lifecycle. Server templates, deployments, and macros are about tracking and collecting all that information for what we used to call systems integration. But now we build that into the process. So if you do it right, the integration step just disappears. You go seamlessly from a full staged environment where you're doing full functional analysis and performance analysis and literally go live with that particular environment or clone it and go live. And that's really a huge step forward in reducing your time to get your product out the door. Version control. Don't need to say more. It's important to track everything. Tracking and auditing everything. And last but not least is cost control. I see a lot of fear in people's eyes when they talk about infinite resources and handing that to developers. It's very, very important to be able to track your costs and to be able to control your limits. So without further ado, I think I have one more slide, right, Betsy? I'm going to do this deployment. I'm just going to take a simple environment, which is what I call the three-layer cake, right? We have a load balancer up front, a classic thing. In production, you might be using an F5 or some hardware load balancer. I'm going to be using a software HA proxy load balancer, which is a really nice one. And in the back end, I'm going to use a master slave database actually provided by RightScale templates from their web edition, which is storage area network base, which allows me to snapshot a copy of the production database with all of its fragmentation, all of its size. You can sanitize it, of course, for your developers to remove those credit cards, and provide this skeleton that I'm now going to drop a deployment into of just this application, just that developer's need. He wants to test something. He wants to develop something. And then we're going to develop that piece of application. We're going to push it into the development and try back and forth and see how we like it, hand over the keys and allow them to literally log into the server in that wonderful cocoon of the load balancer and the database on both sides, snapshot from production, a real production environment, and then they can develop their code for as long as they need to, turn it on and off as necessary to control costs. And without further ado, in a RightScale presentation, we have to launch servers. So Betsy, hand over control here for a moment, and I'm going to launch a few servers here and talk while I'm actually doing this deployment. And we're going to log into the servers like a developer would, and we're going to actually go in there and see what a developer would see when I hand them a deployment and allow them to see what's going on. So I can't see the screen on the other side. So I'm going to ask Betsy, can you see my screen now? Does it look good? How does that look?
Good.
Very, very good. Okay, so what we're seeing here on the screen is the RightScale dashboard. If you're new to what RightScale does, RightScale provides a dashboard that layers on top of the AWS cloud. AWS provides the hardware for us, the virtual slices if you'd like, and we provide a management platform. What it represents, what you're seeing on the screen here, is a collection of servers that wrap around this one news server. I'm going to highlight this one with my mouse here, the application news server that's currently not running. Now, my role today, I was given a request from this developer to provide me a server in the right environment so he could develop a new cascading style sheet or a new template for a Drupal website. So without further ado, I'm going to launch this server. And then while the 3 minutes is happening, while I'm actually launching the server, I'm going to show you the template that I built and the scripts I built that allow me to configure this server. Okay, now when I launch a server under RightScale, it gives me a little bit of a questionnaire. Each one of these questionnaire items has a hint that allows you to answer these questions and make sure the right configuration is put in place. So I've got a lot of flexibility. These templates aren't just a list of things to do. They're also just a list of questions I need to answer. Of course, I pre-answered all these questions, which is how this template would be handed off to QA, all pre-answered. I'll scroll down to the bottom of my template here with all of the things turned on. For example, I've decided the time zone of my server. I've decided its domain name or its URL. And I'll click launch. So got to hit more squarely there. I'll hit launch. I can expect in between 3 and 15 minutes, worst case, a server will launch, and I'll watch my recent activity over here in the recent activity bar and see when the server actually comes up. So what have I done? I've allocated a resource from Amazon. I've requested a server, and within a few minutes, I'm going to get a piece of equipment. I'm going to get a server that I can use, and I'm nesting it in this environment of a load balancer and a database server ready to go. I use the snapshot from production in my database. So when he comes up, he's going to live in that environment. Now, for demo purposes, I've also put in an old server that's been running since yesterday that has a copy of the website so you can see what's really going on here. This is customer facing. So let's look at the write scripts. Design, write scripts, and see what's going on here. The first thing I'm going to do once my server's up is I'm going to install Drupal on the server. Remember, that's the part that comes from the outside. I want to bring in your application. I'm just using Drupal as an example because, of course, in a webinar, I don't want to use anybody's proprietary code. I picked an open source project. I think Drupal has some interest out there, too. So let's get an idea of what it's actually doing. So first of all, let me highlight, this is a bash script. We're not talking about anything complicated. We're talking about simple scripts that do simple actions on the server. They install software. Now, by putting a script out there that does it, I get that repeatability that Bernard wanted. There are no steps to creating the server for my developer that I'm doing by hand. I'm doing this all by script, by write scripts. They exist in the database, and they're versioned. I can keep track of every change I make to it. The most important operative line is right here. I'm getting the application by pulling it in through a wget over the internet. That could be from your source code repository. That could be from another web server through a wget or an FTP get. So I'm bringing in the application for the developer and putting it on the machine in a scripted way. I undo my little bundle. That's the next step. And I proceed to create a directory for it and plop that application right into my server.
Ed, let me just make a point here. Where you've got that that wget, that could also be a call into a source code control system used by a development organization, right? So that's where you'd be picking up the application as developed by the organization itself.
Yeah, absolutely. And if you do an SVN request and you need passwords, the passwords will be SHA encrypted in the RightScale database, so they'll be securely kept in our key ring. That way you can be clear that if you want to use HTTPS access and full keys or SHA encrypted passwords, that we'll take good care of making sure your source code repository remains private. These are your scripts. Very good. That's a very good point, Bernard. And it's important that you can access it, as you can see, from the outside, not just inside EC2, not just from S3 or any of those things. Yeah, you're right, Bernard. You can actually go out to your source code repository.
Right. And let me just emphasize that this addresses that issue of, oh, I'm going to create something and then I'm going to hand it over to somebody else, and they've got to go recreate the whole environment, and maybe I've forgotten to tell them you need all these different components. They're all captured here. So there's not that week-long process of I tried to put it up and it wouldn't work and how come. So it just is automatic and repeatable and consistent.
Exactly. There are little nuances in here, like when I turned off the load balancer health check, I waited exactly 10 seconds. That's the sort of thing that drives the QA person wild. He'll try to redo it and realize, if I do it this way, it doesn't work. I needed that 10 seconds of sleep time to turn off the load balancer. It's captured here in this script. So we know all those nuances of repeatability, and every time I repeat the script of installing Drupal, I get precisely the same install. Now, in the email that was sent to me, the configuration of Drupal, and anybody who's configured Drupal before knows about the site's default settings file. In WordPerfect, there's another settings file with its type. But basically, this is the settings that layers on top of the standard tar application that configures my machine. And here it is in all of its glory. And if you read really, really quickly here, you can actually read all the passwords and usernames to my database. Wonderful. So I'll delete this after the demo, of course, Bernard. And this gives you an ability to custom configure. In other words, my developer can now layer his software and do a custom configuration, maybe turning it to development mode instead of production mode, to turn on and off some aspect of credit card processing, or be able to deal with sanitized databases. All of that's being done here in the script. So I'll whip to the end here. At the end of the script, I make sure the script is all available, and then I turn back on my health check for my load balancer. I've encapsulated the entire process of installing this application without the template we're going to work on next in one script. So let's see how my server's doing over here and see whether it's up and running. My server's operational. Wonderful. So in the time it took me to explain how to install this software, I actually allocated a resource. I set up the basic machine. So I now have an application server up and running. Let's go over to this website really quickly, and you're going to see some 503s and some forbiddens today because, remember, we're developers. I'm going to click on the link, and we're actually going to go to the website. Well, that's what I would have expected. I have a blank Apache running, and right now there's nothing to see. So let's go back to our server and do what any good developer would do. I'm going to log into that server. Notice all I had to do was click on the SSH console link and get myself a login to the server. All of the key management, all the password management, all the complexities of the cloud are behind me now, and I can actually hand this login to the user or the developer, and they can log into the server exactly the same way I am right now, and they're going to see the same screen I'm going to see right now. I'm literally logged into this new server. And let's just type top for a moment so we can see what our server is all about. It appears to be a small instance, and it's not running much of anything at the moment. What a developer would do, kick the tires, look around, see what's there. It seems like this machine's running just right. Now, I'm going to go over to where I know the application is in the machine and see that, in fact, I have an empty web root. The doc group's empty. So let's go and put a file there, and let's see if I really have access to my machine. And put hello in there. That sounds fine. Sounds good. Now I can go back to my website over here that had forbidden, and let's see if, in fact, I'm seeing what I need. Very good. I have a live web server. So this is my classic hello world test. Everything's looking pretty good. Now let's spread out a little further. I have a load balancer in front of this machine. The load balancer is currently talking to the other web server, and I can see that he's talking. By the way, this is a status screen from our load balancer. Similar to an F5, this is a load balancer, and what it's doing is showing me requests that are currently going to app00. I'm just going to go to app00's website and see, yep, he's up and running just fine. And I can see all the nice things on our website. Looks pretty good. The screen's a little bouncy because I've turned off all the caching, and everything's incrementing just fine. So let's now turn off our old web server and start displaying the agility of the configuration management system. We're going to do what's called a write script. Write scripting allows us to do scripts on all the servers in a deployment, not just one. This gives me that agility to configure things. And what I want to do is I want to disconnect from HA proxy my old web server. So I'm going to select my old server. I can select both of them if I wanted to. Let's just deselect the old server and tell him to disconnect from the load balancer. And we'll go through real quick and we'll sort of watch that happen. And you can see when I capture it that as the script happens, there he goes. The old web server is no longer there. And if I go to my website, beware, we're going to see that 503. 503, no server available. So I've now been able to take my old web server out of the environment, displaying that agility. So now I'm in a production environment. I'm actually showing things that are going on. I'm going to now put the new server in. So my developer now has an A/B comparison. It's always great to be able to see one working server and one failing server. So there we go. We'll add one more working server. Go back to our status page and see what's going on. So our application server new is going to come up. Now we're really managing this application, not at a server level, but at a deployment level. We're beginning to see how the developer has not just a single server. He has the entire environment around the server. Now notice that he's checked down. Whoops, looks like we've missed a piece. Let's go back. It is a live demo. Let's go in here and make sure the health check file is there. My health check file is named xyzzy.html, and it can actually just be an empty file. That would be fine. So now I have in my directory the appropriate health check file. Let's hit redo. Now he's up. So my health check file works. So you get the idea. I'm literally on the machine, Bernard. I've handed it to my developer. He can turn on and off health checks. He can add new content, whatever he wants. I guess the next thing I'd like to do would be to layer our Drupal on top of this machine and get the first step in place. Let's execute one more of those write scripts. We're going to go in here and we're going to say, I want to install using my operational script the Drupal site on top of the website as it is here. So let's go into the any scripts and let's run one of our scripts and add to this machine one more layer to the stack. So what we call a stack is everything, all the layers up and down, and I only want to do this to my new server. My old server I'm not going to touch. He's my gold standard that I'm working against to compare what I'm doing. So we'll go into our scripts for our application server new, and I'm going to run that script that we displayed just a moment ago, which installs the Drupal basic install. And while that thing's running, notice it shows up over here in the corner. We're going to very quickly zip over to our website again, and I'm going to type ls. And we'll see that right now I have my code. Everything just seems fine. And in a moment, there it goes. The RightScale dashboard has logged in on my behalf using my key and has installed the software in a repeatable way. So Bernard, will my QA guy be happy about this? Automation of the installation of an application. How's that?
Right.
So now I have,
sorry, not to break in, but also that ability to flip between the old and the new, again, that's vital for application versioning stuff. So I've taken my old version, now I'm modifying it, updating it. This is a way to manage that in the cloud environment. That whole VM proliferation I was talking about, this is a way to address that.
Well, absolutely. But nothing's going to get me anywhere until I get my themes in place, and I don't see my theme directory. Let's pop over and see if my website's no longer 503. Come on, there we go. My website's back up and running, and I'm in good shape. I can now start administering my themes because my developer wanted me to go in here to site configuration and add his theme to allow them to develop new themes. He's a theme developer, right? So if I go down and look at my themes, you'll see that I've got the stack that comes with Drupal. It looks just right. So now let's get back to our write scripts, and let's add, in my case, it's going to be the default Zen theme. I recommend, by the way, anybody who's developing themes, let me pop this over here. This is the default bundle of a basic theme. I'll be using this as a demonstration to represent what a developer would do. But I do recommend if a developer is developing a theme for Drupal, start with the Zen theme. It's a good base place to start from. Okay, so now let's go in here and run my any scripts again. And while that install is happening, right, web install Zen themes, run script, I'm going to show you exactly what it's doing. Back to our design menu. Design, write scripts, install Zen themes. Now, don't expect the script to be very complicated. It's actually quite simple. All I really need to do is, once again, I'm going to wget that tar. Whoops, there we go. I'm going to wget that tar. So Bernard, I've grabbed another piece from another source code repository. So I have a basic open source code repository, and now I have another source code repository, which is contributed themes. Or it could have been my developer's theme. And when my developer's done creating their derivative of the Zen theme, which is a great way to work, I'm just going to change this wget to be the one he created, and then I'll hand that over to QA. That environment allows me to give that repeatability that we had, and there's nothing magic about these things. With a version controlling of RightScale, and that's what this whole button with revisions is all about over here, I can actually see all the versions of this code that I put together. Now, without further ado, let's get back to our machine, and we can see now, once again, the same thing. It's logged in for me. It's created the file subdirectory required. It's created the appropriate pieces, and under settings, we now have themes. I believe it's under all themes. All is in all deployments, themes, okay? And under that, we have Zen. Okay, so now I've installed the Zen theme dynamically. So let's get back to our website, and you're beginning to see I'm working like a developer. I'm actually logging into the machine. I'm in there making changes. I'll have to refresh the screen, of course, expect a little bubble. And now my Zen theme has been installed. We'll accept Zen Classic and do a save configuration. Okay, so now I'm sitting here in Zen Classic configuration, or maybe just basic Zen configuration on this machine, and my developer has the environment they asked for. We have the ability to create for them this piece where now my developer can SSH log in to my machine and work in this environment, and when they're done and they can create that new tarball, right, for me of the new cascading style sheet, we're up and running. And all they need to do is provide me with that piece, and I can add it in. Once that machine's up and running, let's get back to our deployment. I don't want to flip screens too much here, I'm getting you busy. But once that deployment's up and running, and I have exactly what I want, I can now go to this new server, and I can make copies of that server. Okay? So we're going to hit the clone button. The ability of the cloud. I can add more resources when I need them. But I'll highlight once again, infinite resources but with limits. A default AWS account is capped at 20 servers. So your developers can't go wild here at 20 servers until you ask for more. And you can set reasonable limits on all allocations or have infinite limits, whatever level you want. But I think that's an important one to track to make sure that you understand that this isn't without bounds. If you want bounds, you can set reasonable ones. So now my deployment has two new servers, new server and new server v1, and I can trial over multiple servers and determine if sticky sessions is a problem and deal with those issues. And beyond just cloning a single server, and here's where it gets a little wild, I'm going to clone the entire deployment. I'm going to take this test and dev environment that we've built up our environment in, and I'm going to add one more, and let's just rename this QA. Now I have a QA environment. Notice all the servers appear to be not running. Let's get back to the big view of the entire account, Bernard, and see I've taken from development, and I've now created a development and a QA environment. So here I am down in my QA environment with a complete clone and copy of my development. So Bernard, are there any points that I missed? We talked about scalability. We talked about access. Anything you wanted to dive into here?
Well, really, I just wanted to, sort of say, I only wish this had been around when I was running large development organizations, because what you just showed about this clone was anywhere from 3 to 7 days, sort of QA getting the mirrored system set up. This is an incredible ability. And, of course, because it's scalable resources, you're not capped or you're not contending for resources. You can get your own.
And notice that the ones in the QA department aren't running. They're not spending any money here. The only one spending money is development. Until QA turns on their clone, I'm not spending that QA money, am I? So one of the interesting things about the RightScale dashboard, and let's dive that back into the one that's running, is this business of tracking. I want to highlight this line on the screen. My developers and people watching can actually see what this costs. And the incredible cost of this is $16.87 a day. Remember, $16.87 a day, and I have a master slave database on large instances, medium instances. I have a bunch of web servers and development servers. So as long as I turn these on and off in a reasonable amount of time, I'll tell you, I think my Pete's coffee costs more than my development servers nowadays. What do you think, Bernard?
Yeah, absolutely.
And if I were to look right now in the QA deployment, of course, it's 0. and I can turn on and off these servers as I need. Let's do something a little broken here. Why don't I turn on my app server and my development server at the same time, where one has the Zen framework already built in and the other one's not installed correctly, and let's see a live failure of unequal servers. What happens when you actually have one server loaded with one content and the other with another content? Boy, you see this in production all the time, don't you?
Ed, as you're going through this, wrapping up so that we have time for the rest, okay?
Okay, very good. So were there any questions from the audience while we're looking at all these pieces?
Yeah, we've got a couple. We've got one, will I run into complaints from my operations group if I begin doing test and dev in a cloud environment? Bernard, do you want to talk to that while Ed's doing his thing here?
Sure. Well, I mean, the common thing is, is operations going to be comfortable with what I'm doing, or they're no longer controlling the resources. And for sure, it makes sense to include them in the process, in the education process, so they're aware of how you're moving forward on your development and testing. But the flip side is, they're probably going to be relieved because, from their perspective, what they really get measured on is, are the production systems up and running appropriately? So, they view most requests from development QA as kind of interruptions or even irritations. So the fact that you can offload all of that from them is probably going to be a big win for them. So it's kind of informed, but probably going to be a happy conversation is what I'd say.
Great, great. Ed, how are you doing? Okay, we'll take one more question while Ed is working there. If I want to get started on doing test and dev in the cloud, are there particular characteristics of an app that make it well suited for the cloud environment? Bernard, do you want to take that?
Sure, yeah, thanks so much. Well, for sure, it's got to be something that is capable of being run up in a cloud environment, and typically that means an x86-based application. So, if it's if it's a RISC-type system, probably more challenging to move that up in the cloud. Another factor to look at is, again, going back to those integrations. If this system depends on being integrated with other systems, and you don't have service-oriented interfaces that can be accessed from outside the data center, that's going to be a real challenge. Now, you can get around that by recreating those applications and put them in the cloud as well, but that's extra work. So really, our recommendation is to try and find applications that don't have significant dependencies on very tight coupling integration. And that's a key thing to look at.
If you have a very specific piece of hardware like a telephone system interface, a POTS interface, or a graphic array processor, or something like that, as far as I know, there aren't any clouds today that have application-specific hardware that's very, very detailed. But if you're setting up a system that's just based on what you could run in any ASP's hardware, I think everything pretty much well applies. I haven't really run against anything that you can't do in the cloud that you can do in your own data center per se, unless there was an application that required some physical piece of hardware that's literally just not available today, like a telephone interface or something. Back to Betsy.
Perfect. Okay, Ed, why don't you show them, we had a question on monitoring. Why don't we show the monitoring, and then let's flip back to the slides and let Bernard go through the slides. And then after the 12 o'clock marker, we can continue to answer some questions if people want to stick around, but that way we can free up people after Bernard finishes.
Very good. Well, I have not prepared anything for monitoring, but guess what? I know a lot about it. What we're seeing here on the screens is the result of an RRD plot. This is real standard stuff, very similar to Moonin and Agios. We collect all sorts of analytics and information on a per-server basis. Any one of these plots, which is really great because you can see them over long periods of time, like a quarter and a year, all of this information is stored off servers in RightScale databases, is hooked up to the alerting system. The alert system allows you to collect information from each one of the servers. Right now I'm monitoring 74 critical data points inside this deployment. Let me descend down into a single server, And while I'm talking, you can set limits to each one of these values. That way, when something happens that goes outside a bound of a value, you then receive an alert, which you can send to your email system or your pager system. And one of the things I've been experimenting with lately is building application-specific RRD plots using the CollectD plugin, which we do support here at RightScale. And then you can create these limits on your application-specific values. So good examples would be, is the disk free or whatever. I hope that answers your questions. If you have more interest, please go to the support forum. There's a lot of really nice stuff there, particularly focused on CollectD and the ability to collect analytics. So I think the right thing to do, Betsy, is go back to the slides and do the summary at this point. What do you think?
Okay, that sounds great. So here we go. People should have my screens back, and let's go down. Here we go. Here's some advantages. Ed, I think what we'll do is just go, since it is noon now, is let's just let Bernard cover the Jumpstart program and tell people how they can get going if they're ready.
Right. Yeah, thanks so much. Well, so we've had a lot of information about how cloud computing can really positively affect development and test and so forth. And then maybe you've been inspired by Ed's demonstration as to, really seeing how that goes, how the power can play out. And you sort of go, okay, great, I want to get started. I'm ready to use it in my organization. What do I do? And so HyperStratus and RightScale have collaborated on an offering to help organizations really get going with migrating their dev and test in the cloud. And so what we've done is a one-day jumpstart program, basically to help organizations get up and running in the cloud to do test and development. And so it's, we come and spend a day with you to talk about how cloud computing can increase your development productivity. The financial opportunities, in other words, what kinds of financial impact are you likely to see by starting to leverage cloud computing? How do you integrate it with your existing development environment? So we examine that and really identify and make recommendations about how you can work with your own existing development environment. I'll walk through the best practices as Ed has just demonstrated. We'll go through those in more depth. A free 30-day trial of the RightScale VIP level, which is a very advanced level of being able to run cloud environments, and a way to use your own organization. So rather than having a demo, you start to really evaluate against your own environment. And so for this webinar, instead of the standard pricing that we have of $7,500, we are offering a discount, and it's $5,000. And I think the next page has some information on how to get hold of that. You can call HyperStratus. You can email info@hyperstratus.com, and just sort of with an email that says Jumpstart Program, and let us know, and we will get back to you about setting that up for you.
So that's great. So I can get on the cloud. I can see exactly what Ed just did right here. I can see what I just did on the screen and get a full hands-on tutorial from HyperStratus. And with the team, we can get you up and running and doing pretty much what I just demonstrated by the end of the course, right?
Yeah, absolutely. I mean, this is really a way to take what people have seen today and start using it in their environment, which is really the key thing.
Great. Okay, guys, it is past noon. We thank people for coming and staying. This webinar, of course, will be, has been recorded and will be posted on our website in the next 24 hours. So for those of you that need to drop off and get somewhere else, take off. We will stay online for a little bit, Ed and Bernard, if that's all right. And we've got tons of questions here. So we'll just stay on a little bit longer and answer some of these questions live.
Well, I'm game. Bernard, you?
Sounds good to me.
Okay.
Question. What do you got?
Okay, so let's see. How do I control the access and permissions of the developers? Must be an operations person. Ed, you want to take that?
Absolutely. Give me the screen back here for a moment, and I'm going to demonstrate to everybody the worst security practice known to man. I'm going to televise an SSH key and let everybody see how you do all of this. For your information, I will, of course, destroy this information right after the presentation. So every single one of the servers I launched with a form of key called a 509 or an SSH key. So if we go back to our list of servers and I'll go to my server-based new, what you're going to see is the definition of the launch of each server includes what's called an SSH key. And here it is. The SSH key definition for our server new was, of course, Edward M. Goldberg. I'm going to click on that link, and it's going to show me on the screen what this key is. So to give the users access to this thing, I simply cut and paste this key. That is that's the private side of an SSH key. That's part one. I paste this into my PuTTY tool or any other tool that I want to use to SSH into the machine, and they would be able to have access. Now, obviously, there's a part two to this. The part two to this is I'm going to go to app server new and look for the IP address which is publicly accessible to this server. Now, that's going to be this address right here, my public IP address, not the one that starts with 10. That's an internal address that I logged into between machines in EC2, same key. And that public IP address allows me to access using that key. So now I've got the machine ready, and I've given the developer the password, the SSH key, and the IP address. The next thing I have to do is go to my firewall, AWS US is where I launched it, and look at my security groups and see whether or not I have permitted access over port 22, that's the SSH port, to this particular machine. So for our webinar down here, have I accessed port 22? That would require me to remember what's the name here. I believe I use default. And in fact, port 22 is open to that server. So several layers of protection. I have a firewall, I have a key, I have an IP address, and the user without information can do exactly what I did just here, which is log into that server. I hope that answers your question. If you need any more information, once again, the support website's there to help you. Oh, one big hint. You can only log into these servers as root. So the SSH command is going to be root at IP address with key. Back to you, Betsy.
Okay, thanks. I'm just going to get the screen back here for just a minute. So there are a couple others. What would happen if the cloud had business problems? Wouldn't your company be tied to that cloud? You know, that is why we at RightScale have made sure that we support multiple clouds so our customers don't get locked into one cloud or tie their business to one cloud. It is very easy for them to port their deployments, their applications over to another cloud and keep them from getting in this situation. I had another one. What about AWS management interface? Does it compete with your service directly? It doesn't compete. They offer a GUI interface to their API through that management platform. And really what we are trying to build out here is a complete management environment that is sort of a whole another level besides a management console. Next question. So let's see.
Can I add one thing to that?
Yes.
I mean, really, the Amazon interface is designed to help you manage instances and particular objects, whereas the RightScale is really most focused more on how do I manage my applications. So it's kind of a more holistic approach. That's the way we look at it.
Right, and the two, I think, augment each other, Bernard. In my use, I actually use both of them because I find it's really great to be able to get a second guess and see what's going on. It's always nice to have two tools that complement each other so well that I can actually see when I launched an instance that I launched the right number and everything looks correct. It's really nice when you're debugging to not have to worry about second guessing because I get two distinct opinions. But definitely they augment each other, and I think that RightScale is providing that configuration management, as you said, and what AWS has provided is, of course, hardware management.
Great. Thank you, guys. So the next one, so each developer on the team should have their own server in the cloud for them to do their daily development. Bernard, do you want to talk about how you might kind of orchestrate this?
Sure. Well, I mean, this is a classic thing of, you've got developers working independently and then you do an integration process. And, best practices are moving toward, with the Agile of very frequent integrations, maybe even, as much some organizations goes to daily. It makes sense to have a developer have a sandbox that he or she can work on their particular piece, but then you also really use a way to update those changes into an overall build. And really, again, this is where RightScale really comes in, is you can have people do that stuff individually and then create a new version of it that the RightScale goes and pulls. So it does the integration across all these different individual changes, integrates them, pulls them into a single instance that then you do your smoke testing against.
Right. So you have both the collaborative development environment where a whole bunch of users, for example, in my case, are using the same database. And you also have the individual environment where I have one server where the guy was developing a particular theme on one particular server. I could actually have had 3 or 4 servers where each of the developers was developing a separate theme, for example, or maybe a separate section of the website without interfering, but everybody sharing the database, because sharing the database gives them all that content to play with.
Great. There's an interesting question here. I would love to see how it is possible to take the features from a development server and to take the latest content from production live server and create it automatically a new stage, and then stage a new server.
Can I address that?
Yes.
Go right ahead, Bernard.
Well, really, I mean, we've seen exactly that. I mean, you know, by Ed creating the new theme, that's in effect the new development, the new functionality, but it's still going against the same database, which has the same content of this overall development environment. Now, if you're sort of saying, well, how can I take production content and make that available? Well, obviously one thing you can do is do some kind of a data dump, a backup, and then install that into the test environment, and that's probably what you want to do. Again, keeping in mind that you might need to sanitize that, scrub that data. But those are, those are the 2 ways you can do it. One is you've got a development environment that has data, and you can share that across the new development, each individual developers, or you can copy out content from the production environment, do a database backup, and then a restore into your development environment. And those are 2 ways you can go about that.
Now, let me add about the network attached storage stuff. Within the EC2 environment for AWS, each cloud is, of course, different. The backed up databases we use a form of snapshotting technologies using a storage area network, or just like an attached disk, if you'd like, which self-backs up. What's interesting about this is that when I grab from a production backup a snapshot from a point in time of that, first of all, I don't interfere with production. I'm just looking at a backup. And I get that information as scattered, gathered, and as unordered as it is in real production, with all the messiness of doing the queries against random data. So now, when I launch these servers against the snapshot from production, for my little Drupal example here, I'm getting that messy Drupal database, a backup of production. 2 things happen. First of all, I just validated my backups work. I love that feature. And second, I get those queries with all the slow query issues due to scatter, gather, and table fragmentation that I would have had in production. So, wow, this is a very good question, because it does allow me to build a real environment for my developers that not only mimics production, but also complements the testing of production. Back to you, Betsy.
Okay, great. Next one. Do these instances have to be turned on or off from the RightScale dashboard, or can we do that via APIs?
Oh, you can even be simpler than that. Just go to the machine and type halt, and you stop paying for it. The individual developer can be handed a machine. I do this all the time. Provide a machine, send them the SSH key and the IP address, use it for as long as you need today. When you're done, simply type halt or shutdown -H now. The machine halts, stops spending money, and disappears physically. So yes, I can do it from the dashboard. I can do it from the API. I can have one computer launch more computers through the RightScale API, also through the AWS API. But also, a server can simply be turned off by the developer and stop spending.
Yeah, and one of the advantages of doing it, though, through RightScale is that we gracefully decommission servers and save the data that companies often need later.
Right, you need those audits, and you want to know how long they spent. But by the way, when you decommission a server by halting the server, those audits will also be entered. it actually marks termination and shows you that the server was terminated by the user on behalf of the server.
Perfect. Okay. Does this also scale your database without modifying your code at the app layer?
Bernard, you want to take that one? I think he wants everything.
Well, I mean, one thing you can do is if you need more scalability, more horsepower, you can run the database on a larger instance, and that'll give more processing power. So
Yeah.
that's one way you could scale it.
We also have two partners that address database scalability in two different ways. So Nick, if you want, go to our website and look through our partners. And there are two of them there that do database scaling, and they have templates ready to go to be incorporated into RightScale. I also had I had an Oracle question. We are working with Oracle to deliver 11G through the RightScale platform. You know, I think a lot of the rest of these are very detailed in nature, so I think we've covered the basics here for people. Is there anything else that Bernard, you or Ed want to say as we close it out?
Well, I'd just like to thank you for inviting me to participate and talk about this. You know, this is dev test is coming to the fore as one of the primary use cases that organizations are moving forward with in the cloud. And you know, given kind of the challenges of traditional development and leveraging the cloud, I mean, it makes a ton of sense. So thanks very much for letting me come and speak about that.
That's wonderful. Thank you, Bart, for being here. I only have one thing to add, Betsy. I'm going to be in New York Monday afternoon at the Marriott Hotel at the AWS walk-in meeting. It's called the Startup. So if you want to address questions directly to me and you just happen to be in New York on Monday morning, please drop by to the RightScale booth, and we're going to be talking, and I'll be there physically in person, and we can talk through any questions you have at the Marriott Hotel in downtown New York City.
That's great. And if you want to see any of us here at RightScale live, November 2nd, we're having a user conference. It is in Santa Clara in conjunction with Cloud Computing Expo. If you go to our site, all the details are there. So with that, we will sign off. And for you last 46 attendees that are still with us, thank you for sticking around this long.